Okay, so DeepSeek might have just stumbled upon one of the biggest upgrades to how we build AI brains. Seriously, it's this fundamental shift in how these models think, moving way beyond that old idea of just make it bigger. And this whole new approach, well, it all kicks off with a really simple question.
So what do you think is AI's biggest waste of time? I mean, what's the single most inefficient thing that even our most advanced models are doing every single second of every day? It's not a trick question, I promise. And the answer, it points to this massive blind spot that researchers are now racing to fix.
It's this. They're constantly relearning the same simple stuff over and over again. Think about it. Even the most powerful models are recomputing the meaning of common phrases from scratch every single time they see them. It is the colossal, almost absurd waste of energy that's been holding AI back. And to really get why fixing this is such a game changer, we got to take a quick look at how we even got here.
Right, so for years, the main strategy in AI was super simple. If you wanted a smarter AI, you just made it bigger. Throw more parameters at it, more data, more compute power, and hey, for a while, it worked. But then we hit a massive wall. These models got so gigantic that running them was like trying to power a small city just to answer a single question. It got insanely, prohibitively expensive.
So, the AI world came up with this really clever trick, kind of like a cheat code. It's called Mixture of Experts, or MOE. The idea is, instead of having the entire AI brain light up for every single thought, it only activates a few specialized parts, these so-called experts, at a time. This let models get huge in size without needing a ridiculous amount of compute for every task. It was a massive breakthrough, for sure, but it was still missing something really, really important.
Yeah, even with this cool Mo trick, there was a much deeper problem lurking underneath. See, these AIs have an incredible amount of knowledge, right? But what they lack is a true, fast associative memory. They know what something is, but they don't recognize it instantly, the way you and I do.
And this comparison here just nails the problem perfectly. When you see the name Alexander the Great, your brain doesn't have to start from scratch to figure out who that is. The concept is just there, bam, instantly. But an AI, even if it's seen that name a million times, it still spends a ton of computational power internally rebuilding that concept every single time.
I love this analogy the researchers used. It is just so good. It really is like having a friend who, every time you mention a celebrity, acts like it's the first time they've ever heard the name, and they have to reconstruct their identity from clues. It's just deeply inefficient, right? The internet is packed with these repeated names, phrases, common patterns. Forcing an AI to recompute all this simple stuff again and again is a huge bottleneck. It stops it from using its brain power for what really matters, actual deep thinking.
Okay, so this is where DeepSeek's big idea, called Engram, enters the picture. The whole philosophy behind it is beautifully simple. What if we just gave the AI a fast access memory module, specifically designed for all these common patterns? Then the main thinking part of the brain could stop wasting its time on the easy stuff and actually focus on real complex reasoning. So here's the breakdown of how it works. It's actually pretty elegant. First, the model sees a common pattern, right? Something like United States. Instead of starting to think about it, it just instantly looks it up in this huge memory table. Think of it like a giant, perfectly organized warehouse where every common phrase has its own spot on a shelf. The lookup is almost instant. But, and this is the really clever part, it doesn't just blindly trust whatever it finds. There's a little truth detector, a gate, that checks if that memory actually fits the current context. If it does, great, the info gets injected into the AI's thought process. If it doesn't fit, it's suppressed. So the memory is like a super fast assistant, not the boss.
But that brings up a really important question, right? How much of the model's brain should be dedicated to memory, and how much should be left for the thinking experts? You can't just max out both. And what DeepSeek found is that there's a real sweet spot. If you have too few experts, the model kind of loses its power for deep thought. But if you have too little memory, well, you're right back to wasting time on simple patterns. They discovered that the best balance is dedicating about 20 to 25% of the model's capacity to this Engram memory.
All right, so the theory sounds really good. It's elegant. But the big question is always, does it actually work in practice? So DeepSeek built a few different models to really find out, putting Engram head-to-head with the traditional MOE model in a performance showdown.
So let's look at how they set up this test. They started with the baseline model, a 27 billion parameter MOE model. Now for the Engram version, they didn't just add more parameters. That would be cheating. Instead, they actually took away some of the expert capacity and reallocated that power to the new memory module. This is super important. It means the Engram 27B model has the exact same compute budget as the baseline. It's an apples-to-apples comparison. It's just that a chunk of its brain is now a fast memory library. Then, just to see what would happen, they scaled it up even more with a 40 billion parameter version.
So, what happened? What were the results? Well, first, we got the outcome everyone kind of expected. On general knowledge tests, the Engram model did way better. You can see it right here on the chart. The score just jumps up from the baseline model. And that makes total sense, right? If you give an AI a better memory for facts, it's going to be better at answering fact-based questions. No big surprise there.
But here's where it gets really interesting. The big surprise. Engram also boosted performance on tasks that feel like pure thinking. Stuff where you'd think memory wouldn't matter nearly as much. Things like math, coding, logical reasoning. They all got better. Just look at the math benchmark scores here. The performance goes up. And at first, that seems totally backwards. Why on earth would a memory module for common phrases help an AI solve a math problem?
And that surprising result, that gets to the absolute core of why this research is so important. It turns out, this isn't just about simple recall. It's about freeing up the model's capacity to do deeper, more complex work. It's about thinking.
Okay, so here is the crucial insight. In a normal AI model, the first few layers of its neural network are basically wasted doing repetitive grunt work, like recognizing New York City for the millionth time. But Engram takes care of all that low-level stuff instantly. And what that means is the model gets to a deep level of understanding much earlier in its process. The researchers actually found that the information at just layer 5 in the Engram model was as complex as the information way down at layer 12 in the baseline model. So it effectively makes the AI deeper without actually having to add more layers. It's just more efficient.
In this effect, it becomes an absolute superpower when you're dealing with really long documents. Because Engram is handling all the small local stuff, the model's main attention mechanism is totally freed up to focus on the big picture, connecting ideas across thousands and thousands of words. The results are just stunning. Performance on those needle in a haystack tests, where you ask an AI to find one tiny fact buried in a massive document, jumps from 84% all the way up to an incredible 97%.
But here's the question that always comes up with new AI research, right? It's a really cool idea, but is it actually practical? Can this run in the real world? I mean, adding a giant memory module, that just sounds like it would slow everything down to a crawl, doesn't it?
Well, nope. Turns out that's wrong. DeepSeek engineered this thing so efficiently that even if you have to offload a massive memory bank to slower CPU memory, the maximum performance hit is a tiny 2.8%. Let that sink in. This proves that Engram isn't just some cool idea in a lab. It's an incredibly practical breakthrough that can be put into real-world systems without a huge penalty.
So after all that data, all those charts, what's the crucial point here? What's the one big idea we should all walk away with? What does this actually mean for the future of AI?
Here it is. By giving an AI a simple memory, we don't just help it remember facts, we free it up to think. That's the real genius of Engram. It's not just that it improves an AI's memory. It's that by handling the boring, repetitive parts of language, it frees up the AI's core brain power to do deeper, more complex, more nuanced reasoning. We're not just building a better encyclopedia here. We are building a better thinker.
And that leaves us with a really fascinating final question to chew on. If a better memory is the key that unlocks deeper reasoning, what abilities might AI gain next? This shift in architecture from just pure computation to this hybrid of memory and computation, it's already unlocked these surprising new abilities. So you have to wonder, what comes next? What new cognitive doors are about to be blown wide open as we continue to build AI, not just to calculate, but to truly remember and recognize?